Today on Switch to Linux, we are going to talk about expanding the physical and logical volume of an encrypted drive in the event you need to enlarge the hard drive inside of your computer. If you like this type of content, please feel free to subscribe to the channel, leave us a like and a comment down below. Welcome back to Switch to Linux. Thanks for checking out this video. Well, today we are indeed going to take this laptop of mine. This is the infamous laptop that I bought at a pawn shop for about $100 because they're like, I think the charging port's broken and we'll just pawn this off on somebody. Joke's on you, boys. I know how to fix computers. And of course, charging port for this computer is $7 and it takes 10 minutes to change. So I actually bought two of them. So one of them is in there. And since it's such a thin one, I do not like these new Dell design. Their charging cables are just too thin. And so these newer ones do cause problems. Fortunately, they are easy to replace and they are cheap and easy to get. But the other thing this computer had is 8 gigs of RAM. We spent just a few bucks when I first bought it a few years ago, upgraded the RAM to 16. That's no big deal. And it does only have a 256 gigabyte SSD. Well, that's ridiculously small considering the fact that modern SSDs, like this one here, Western Digital Blue, cost me $60 for 1 terabyte. So we're going to expand the drive on this up quite a bit. So we're going to go ahead and talk about all the different steps. Now, usually if your drive is not encrypted, this is quite simple. You duplicate the drive, do DD, or in this case, we're going to do Clonezilla because it's just easier to work with. And then you just go into gparted and expand the volume. No big deal. Well, when you have an encrypted drive with logical volumes, a little bit more complicated. In fact, there are many resources online that say you can't even do that at all. Balderdash did it. I'm going to show you how. So you are going to need some extra tips or some extra tools and things. First thing, let's keep in mind, you might be able to find some of these, but they are not what we're looking for. I'm not sure they make these anymore. Let me go ahead and focus in on this guy for you here so you can see what we're looking at. This is, if you can focus, there you go. This is an old school. This is when they first started running the M2 slots when they had SSDs. These are not the same as the modern drives, which are NVMe. So you'll notice the difference. Now, what you find here, you're going to look for this. Now, you do want to make sure, does your computer have the older port, which needs one of those M2 SSDs, or is it need an M2 NVMe? They are two completely different chipsets. They are in no way cross-compatible. So make sure that you know what you're doing. Now, the next thing you're going to need is you are going to need an adapter. You can pick these up online for a few bucks. From Walmart, I actually got this PNY upgrade kit, which contains a 1 terabyte drive and it contains the adapter. Now, this was the drive that I tested what we're going to do today on. So I do have a backup of that, but I'm actually going to use this drive for doing some real hardware distro testing in the future. And we're going to swap the one in the computer to this Western Digital one. And I'm not sure. Let me know in the comments. Do you think the Western Digital is better, or do you think that the PNY drive is better? They're both 1 terabyte. The other tools that you are going to need, you're going to need a drive. So you want a live key that you can either install or hopefully in our modern times already has the Lux encryption tools built into it. For this case, I'm going to use Linux Mint Mate on a live key because that's what I had easily on my computer. Now I have one drive which is Ventoy. And of course, you can watch the Ventoy video. Very easy to build. One drive can boot multiple different distributions. And so this Ventoy drive, I have the Clonezilla on it, and I have the Linux Mint on it. So we're just going to use this drive for all of our multi-booting as we need to boot in first to Clonezilla to duplicate the drive, and then we will need to boot into Linux Mint to actually do the expanding of the partitions. The next thing you are going to want is you're going to want a powered USB 3 hub. So that's what I have here. We have a USB 3 hub and we have the power. Why do you want this? Well, in my original tests of trying to duplicate this drive, because the power is coming from the same port as the data transfer, not only does the drive get much hotter as it's trying to transfer the power, But it also, what happens is, and you might have seen this if you're moving big files, maybe movies or distros around on drives, it'll start really strong and then it just drops down to like a megabyte a second or something, where you want multiple megabytes a second. In fact, I was dropping down to like 250K a second. And we're talking about duplicating a whole drive. So if you're just plugging our adapter right into the USB port on the computer, this thing was reporting me it would take 12 to 15 hours to duplicate. But if you use a powered USB 3 hub, and make sure it's 3, make sure it's not USB 2, you use a powered USB hub, it's going to take 15 minutes. So that's your difference. If this thing is providing its own power to the drive, it is going to transmit the data way faster and keep everything way cooler. So if you're like, oh, I don't know about that, it's worth having one of these guys laying around. So we're going to go ahead and do that. And then, of course, you need your new drive. And we do want to make sure we have full backups in place. So prior to this video, I have backed up all of the data on this computer that we are working with. So in the event I make some goofy mistake or something, I have not actually lost anything. I just need to reinstall the operating system. So let's go ahead and open this guy up here. We're going to go ahead and run with this. But if you guys let me know in the comments really soon if the PNY is infinitely better, hey, I will actually have a duplicate of this same operating system on both drives at the end. So here we have it. Here is our Western Digital, and it looks great. Now, there's one more thing to keep in mind, though. There are 3 different sizes of these ports. Okay, there is a, this one here is a 2280, there's a 2260, and there is a 2240. And to show you the size, this is actually an adapter for the other SSD. Let me go ahead and get this guy focused. Okay, I think that's pretty focused. So you can see the 3 sizes. Now, the one that's in the laptop right now, I think is this smaller size here. And this one is the larger size. So you do want to double check your laptop in the case it's a laptop to make sure it can take the full size. You don't want to end up doing all this stuff and then be like, oh crap, I can't fit it. And in my case, I did open this guy up and I double checked. Well, I hope I double checked. Hopefully it's not like a 2260 or something, but I'm pretty sure I did see it was a 2280. I did test it with everything to make sure we had the right size. So just be aware there's different sizes. Of course, at Walmart, the only options I find, even at Best Buy, the only options I find is the 2280. So if you do need like a 2260 or 2240, you'll probably have to go ahead and buy that online. Those are the individual components that we need to make this work. So now let's go ahead and jump on over to the computer and we will have a look at what our next steps are. So here we have booted into the computer and you see here I'm on the one-time boot manager by getting into the F12 key. So we're booting off of the Ventoy, which is my SanDisk. So I went ahead and selected that one. And now we are going to click on this guy here. And this is all of the operating systems I have on my Ventoy right now. So we have Blend, we have a couple Clonezillas. I keep 2 versions of Clonezilla on here just in case there's something wrong with the previous one. And we're going to come down here to, actually we're going to do Clonezilla on this one, right? So we're going to go ahead and click on Clonezilla. We're going to click into normal mode. And this is going to get us over to here. Now, my apologies, I cannot run a screen capture on this. Because it's a laptop, I just cannot get Clonezilla to run out of the HDMI port. And I have tried multiple times, and I have never had any success. I'm going to run it into RAM, so you probably can't see those options there. Let me try and adjust this a little bit, see if you can see those options. There you go. Okay, so now you can see the options up here in this corner. I'm taking 800 by 600 and booting it into RAM. So here is our hub setup. And you can see that I have the laptop plugged in here. Here's my Ventoy. These are both in USB 3s. And I have a mouse set up over here if I need it. Although Clonezilla, I don't need the mouse. I'm not sure why that's set up. So while that guy boots up, we're going to take this guy here. So I've already put my SSD into my adapter and we're going to plug this in. Now this USB port has power on, power off switches. So I can just plug into either one and then push the power on switch. Okay, so I'm going to plug this guy in, push the power on switch, and that is ready to go. That's going to sit in the back. So now Clonezilla is booted up. It wants us to start by selecting our language. So English is good. We're going to keep the US keyboard layout, which is the default. And now we're going to hit the Start Clonezilla. The mouse is actually active. I'm going to turn that off so I don't accidentally hit something with the mouse. So now we have options to choose from here. We have device image work, which works with disks or partitions using disk images. We have device working directly from a disk or partition. We have remote source, which goes from any remote source onto the clone. We have remote to destination, and then we have some servers. I don't know anything about the servers there. What I do is device work directly from a disk or partition. So we're going to do that, and then this is going to boot up some options, and it's going to search for all of the available drives on the system, and it will detect 4. So here's beginner or expert mode. I'm going to hit beginner mode because most of the stuff on there is works by default every single time I've done this. And then disk to local disk or partition to local partition. We're going to do disk to local disk, which will clone an entire disk, including its partitions. So we click enter there. You'll see down the very corner there, you may not see that, but it says disk number 4. So the 4 disks are the internal SSD, the external one that we are cloning to. There is an internal SSD which runs my cubes, and it also sees the Ventoid disk. So now it's going to choose a disk as the source. Okay, so this is the disk that everything is coming from, and we have a few options. We have NVMe 0 and 1, and that's 256 gigabytes. That is the drive that is our source. That is the current internal drive of the computer. SDA is the 120 gigabyte SanDisk drive. That is my cubes drive. Yes, that desperately needs expanded. We have SDB, which is the Ventoid drive, and we have SDC, which is a 1000 gigabyte Tech PCI. That is the name of the USB adapter. So that is the one we are using as our destination. So since this is our source, so we're going to select this one as our source. So click OK. And now it's going to look for all of the remaining disks, and it's going to give us the 3 remaining ones as destination disks. Now you have to use the same size or larger disk. So obviously we couldn't even successfully clone it to the other 2 because they're smaller disks. But we are going to pick the last one, which is our Western Digital drive. And then now we can skip checking and repairing any source item files. We can interactively check and repair source, or we can automatically repair source files before. I'm going to use the option to skip. I'm pretty confident things are working well, and even if it's not, I have all of the data. I can reinstall the operating system if I have to, so I'm okay with the first option. And then I will, of course, rigorously test the computer before I mess around with any of these other drives that have the copy of the system on it. So now it's going to choose the mode to create it. So the first one selects the partition table from the source disk. The second one is creating partitions ourselves, and the third one is an exit. So we are going to use the partition table from the source disk. So the action to perform when everything is completed, we're just going to choose what we're going to do next. So that's what I want to do. Now we have to hit enter to continue on, and it's going to give us multiple different chances to back out. So warning, 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 everything on this particular drive will be erased. Yes, I'm sure I want to continue, and it asks us the same question twice. We're going to go ahead and do that. And once this is done, it's going to take some time. Now, this is the step where if you're not using that external powered USB 3 device, burning this onto a USB 3 adapter like I'm doing here, this will take hours. But since we're using this adapter, it will take roughly 15 to 20 minutes to do. At least the last time I did this in my test build. So you can see it's doing all of its thing, and effectively from here, you just watch the tables go by. So I'll kind of sit here while it does the first, and then we'll stop here. So this is, it's doing the very first partition, which is only 500 megabytes on FAT32. That is, I believe that is our boot partition that gets cloned into the boot. This one is 767 megabytes. Not sure exactly which that partition is for here in Linux Mint. But then the third one, this is the one that'll take a while. So this is the data partition. So it's 254 gigabytes. You can see right now it's transferring at 754. Now it's at 8. And what you notice is this number here keeps going up. Well, if you're doing this without the powered USB port, that number keeps going down. And that means it's taking longer to clone. So right now it's telling me it's taking 26. But as this number keeps going up, this number keeps going down. I saw this peak around 18 gigabyte per minute. And so that's about how long it is taking. So we're gonna go ahead and turn off the camera here, and then we will turn everything back on as soon as we are ready for our next step. As you can see, 15 minutes has elapsed. We have just completed this step here. So it's syncing all this data now, and it should go through its final double check steps, which takes just a moment here. So it says down here, cloned successfully at the very bottom, and then it's going back into just double checking everything, checking if there's anything else it needs to do. It looks like it's actually running a grub install on SDC. So it's skipping the reinstallation down here, probably because this is encrypted, which is just fine because the original installer should work just fine. Now we need to hit press to enter, and it goes back off into our system. We're going to go ahead and power this down, and we're going to boot off of that drive now and see if this works. All right, so I removed the Ventoy disk, and now we have a variety of options here to choose from. So this first hard drive is the internal one that will boot our small drive. This is another call on the same hard drive. No, I'm sorry. The first one is actually the cubes. The second one is our internal drive. Although this will not actually boot. I actually have to go down and select the cubes for that. One of the security things I have in place. So the Micron Tech, this is the one that we just cloned. So we'll go ahead and boot into that. You can see it goes right on into our Linux Mint boot up, and it will ask us for our decryption password for our Lux encryption on the drive. That's set up successfully. Got to log in. Okay, so everything over here looks like it's working. Let's go ahead and explore the disks real quick. So we'll go ahead into our disk manager here. So you can see it says 1 terabyte disk. You'll see though that we have free space over here that's not used. We have our partition over here, which is our 256 gigabyte. And then of course, if we boot up Nemo here and have a look, you'll see that the free space is still 76 gigabytes, and you'll see that the whole drive, when you add these guys together, is still the same 256. So that's kind of what we need to fix, right? So that is going to be our next step. So we are going to be able to capture that on the capture card. So we're going to go ahead and boot into this on a live key for Linux Mint, and we'll walk through the steps that you need to follow in order to go ahead and clone this, basically expand the logical partition. All right, so now we need to do a couple different steps here. The first thing I'm going to use is I'm going to use the GUI gparted tool because it gives me an easy ability to resize the free space into the partition. The problem is an encrypted partition does not just consider what's there because it is managed with Lux and LVM. So there are other steps that one must do in order to expand it beyond what is in the size of that partition. So we're going to use an Ubuntu help guide in the terminal, and we're going to explain what's going on with that. But the first thing we need to do is use gparted. This is where you use a really good installer, like a live key for whatever your distro is. Since I'm doing this on Linux Mint, I'm going to use a Linux Mint live key, which is the best thing to use. Now, there are some steps on the guide, which was written in 2015, 9 years ago, which we can easily skip because things have changed quite a bit. Most distributions are coming with encryption enabled by default, so there's a few steps that we can skip, but we'll walk through what those are just in case. Also, you need to make sure gparted is installed, but again, on most install live keys. gparted is installed even though if the distribution itself does not have it installed when you start. So I went ahead and booted into Linux Mint 22, just whatever standard way. In this case, I used my Ventoy disk, used Linux Mint. So now we are on a live key, so we're going to jump on over to this computer. So over here on the computer, you can see that we have gparted is installed. So we'll go ahead and boot this guy up. And gparted allows you to make changes to drives. So you can see that we have two different disks on here. This one's the Ventoy, this one SDA is our partition, and you can see there's unallocated space. So what I want to do is I want to come in and select the partition that we want to change. I'm going to right click and resize/move. And so we're just going to drag this bar all the way to the end and say resize the drive. So do you want to do this action? The answer is yes. So it says everything is completed. We're growing the partition from 237 gigabytes to 930 gigabytes. You say, great, now we're done. The problem is this guy is LUKS encrypted with an LVM. LVM still only knows about the 230 gigabytes. So we have to do extra steps involved here. So now we are going to have to inform the LVM and the encrypted partition that the size of the drive has changed. So let's go ahead and do that. So the help document is over here. I will have this in the description. It's just resize encrypted partitions, and I'm going to pull up a terminal, which I've already made nice and big so you can see what we are doing. So we have a physical partition. That's what we just changed. We changed the physical partition, but that does not inform any changes to LUKS or the LVM as to the actual size of the drive. And so if I go in, I do the crypt or LUKS container. This is the actual encrypted part. The LVM is what is reporting the data that is there. And so we're going to go ahead and set this guy up. So let's look at this first part here. We don't need to manage any of this. This is just how to manage different encrypted partitions on a live key. But this also is an old article, so it assumes that the LVM and crypt setup are not installed on nearly everything every system now. These are set up, these are installed, all this stuff works out of the box. You can always tell by plugging in an encrypted drive and trying to decrypt it. Of course, that's a really stupid way to do it, and you could risk data corruption. Don't do it that way. Just be aware that you need to do that, and then you need to make sure that the module for decrypt is in setup, which it also should be on any system. We'll go ahead and run that step just in case. Now, this is resizing. So first, reducing the size of a partition. It is unsafe to reduce any partition, encrypted or not. You will risk data loss. Increasing a partition size is generally safe. Here's the basic principle. We want to go in and enlarge the space of the encrypted drive. We want to inform the LVM, change the root file system and the root logical volume as well. So that is the step we're going to do. We're going to skip on down to the bottom to where he has the detailed instructions on enlarging the encrypted partition. So this is what we're going to do. Now his first couple steps is the extra paranoia. You can do this if you want. Basically he says you want to go in and create an encrypted partition and then overwrite it with zeros. We're not going to bother with that. Hopefully this drive was actually new, that I just bought new, and it was not returned with bad stuff on it. Regardless though, changing it into an encrypted partition should be safe anyway, but we'll go ahead and skip the first couple sections. And then we do not need to install these into the system, but I'll go ahead and show you what that might look like anyway. Of course, this is old. We don't need the apt get. Apt is just fine. And it's going to tell us that these are already the latest versions. We don't need to do anything. This should already be activated, but it does not hurt us to run the command a second time to be sure. And now the next step we need to do is we need to open up our LUX encrypted drive here. So this step here is calling the the crypt setup is the LUX encryption. This is telling it to open, and then we have to go to where the partition is. Now this instruction says SDA5, but that's actually not where our partition is. You can always check your disks to see where it is. You can see here that this is partition 3 is the LUX encrypted. So we'll go ahead and change that SDA5 to SDA3. So we'll copy and paste this guy in, change that 5 to a 3. And we have to enter our decryption key, which is going to be the same decryption key you had before. As long as you don't have any error, if you go right back to a prompt, then that is set up correctly. Now we are going to activate the LVM. So it finds the group vgmint using LVM2, and then this is going to activate it. So now we have two groups set up in vgmint, and these are vgmint-root and vgmint-swap. So now, before we actually do the decryption, we're going to do an fdisk real quick, and I'm going to show you why. So when we go down here, you'll see that the vgmint-root, this is the actual encrypted drive, you can see it has 236 gigabytes, but remember that the size of our drive is like significantly larger than that, right? So that is what we're going to be fixing over here. So now what we're going to do is we're going to resize crypt1. And we have to enter our password to do that. And now we're going to resize the logical volume. So one physical volume has been resized. So this is going to lock in the LVM to the size of the actual drive. So now we're going to actually resize the root. And this guy here is correct still, but the next step we're going to need to make an adjustment. So one physical volume has changed. Now we need to set this up here. Now remember that our group is vgmint. This assumes our group is Ubuntu VG. So we're not going to be doing the dev Ubuntu VG root. We're going to be doing dev vgmint-root. And let me just show you that real quick. So if we go over into dev, you can see we have vgmint over here. So go into vgmint, and this is where we have those two volumes, root and swap. So we'll go back to our main root. Now we're going to run this command here. So the resize, now this plus 4G is giving us a size. This is just adding 4 gigabytes. We don't want to do that. We want to use, whoa, I don't have my number lock turned on. Let me go ahead and fix that again. All right. And there's a space before that. I don't know why. All right, so we're going to remove this. We're going to change this to 100% free, which tells you to resize it to all available space. But this is not Ubuntu VG root. This is the name of the volume group that it tells you above, which in my case is vgmint. So once we do that, the size of the logical volume has changed from 236 to 923. And so now that has successfully resized. And now we're going to relock it. And then the last thing we're going to do is change the file size. Now, these guys here are also different. So let me go ahead and show you what these are. So let's go into dev and mapper. Do an ls there. You can see that these are vgmint-root, not Ubuntu-vg-root. So we need to change this to vgmint-root in that step there. So let's, let me go back to my root just to make sure there's no goofiness going on there. So this is where we change this to vgmint-root. So it's checking the inodes, blocks, and sizes, checking the directory structure. Everything looks good. And now we're going to resize the file system. Once again, change this last line to vgmint-root. So that says it is good. So now let's go ahead and run that fdisk again. And so now you can see that the vgmint says it is at 929 gigabytes. So now we have properly expanded our partition. So let's go ahead and reboot this system using this and see if that works correctly. So let's just do a sudo shutdown hnow, shut everything down. And again, I use an icy dock in this computer so I can turn on or off my hard drives. Oh, there you go. Look at that. It found it. It I didn't have to do anything else. So now this is a Linux Mint 22, which we have just changed the encrypted volume from our 256 all the way up to the full size. All right, so now that we are booted in, let's go ahead and just pull up Nemo for simplicity. You can see that now we have 763 gigabytes left, so we have successfully cloned our drive into the system. So of course we have one final step, surgery on the computer. Let's go ahead and do that next. All right, now for the surgery of the computer. So we're gonna go ahead and use my handy dandy screwdrivers here, and there are several screws on the back of this particular computer to pick up. So we're going to do that, and then I have a nice little magnetic device over here so I don't lose any. And then there are two different sizes of screws on the back of the system, although the other ones I don't think they come out all the way, so we'll double check. But I have so many computers here that I've worked on all of them, I can't remember which one's which. Okay, the back four screws do not come out, so we'll just gently set that over there. So here you can see the inside of this guy here. This is where we have our secondary hard drive, our SSD, which is running cubes. And our SSD is over here. And then I've talked about the power port before. That is on, I believe, this side over here. So what you need to do for that is you need to pull out the wireless card right here. And then the wires will route around here, and I'm trying to remember exactly which way it goes. So it plugs into this port right here. So you've got to pull these wires out, route it around here. Many of your guides will say you got to take apart 15 other things. You don't. You just need to take off this hinge cover as well. Lift up this hinge cover, and then you can swap your power port in. Here's my two RAM sticks over here. Everything else in this computer is pretty nice. There's actually two more. I'm not sure what those power cables are for. It looks like maybe extra fans or something. But let's go ahead and swap this guy out here. There's two screws here to take out. And here is where your SSD is. Ooh, that's a tiny, tiny screw. I think this might be able to get to that, though. Let's see. Nope. I'm going to need my extra tools for that. Need my micro tools for that one. That is a small screw. I don't even know if we necessarily need that cover there. I'm going to see if that cover actually gets in the way or if it's going to be good. So what I don't want it to do, yeah, that cover's not going to work, so we're just going to run it without the cover. All right, so before we actually plug all the screws back in, we're going to test the guy out, make sure that everything works. There we have it, folks. It is working just fine. We have our full disk space available, and we have successfully cloned this, and everything appears to be in working order. Of course, we're going to do a little bit of testing before I do anything else with that other drive. I'm not going to change or mess up or do anything else with that other drive. I'm going to keep it in a nice, safe, secure location while I test this out quite thoroughly. And then once I've tested this out quite thoroughly, run updates, all that kind of stuff, then once I am confident, then we're going to proceed with this system as the fully expanded system. So there we have it, folks. There is how we change that. Of course, the last step, we're going to power everything down and tighten everything back up, and we'll call her good. So these two screws in the corner actually do not come out. These ones actually do come out. So they plopped out, but fortunately they plopped right on my table. So I have them all there. Alrighty, let's give her one final test, and then I'm actually going to run system updates. So we'll see what this guy finally does. Then, of course, I did realize that I use this computer to capture our part, so I'm going to have to use my adapter to pull the data off of this little chip. So that'll be fun. All right, so everything is now working just fine. We have this all worked out. I will leave as a sub-note to the video, very, very end. We end up putting the PNY in here as the final analysis, as one of our hardware guys on our Matrix channel said that the Western Digital Blues tend to have issues that lead to a greater chance of failure. And so I decided I'm going to run the PNY in this instead of the Western Digital Blue. So let me know if you think that was the wisest decision or not, and then we'll just use the Western Digital Blue as a distro testing, because hey, if that blows up and fails, who cares? I'll buy another one. Anyway, if you like this type of content, you want to see more of these types of videos here, let me know in the comments down below. I don't do a lot of the tutorials here, but honestly, maybe I probably should. Let me know. With that, thank you for watching. Leave a comment, and definitely let me know which one of those two drives you think is better. And we will see you in the next video.